Okay, hey everyone, let's talk about the next part for this chapter 15. We are going to try to cover the entirety of life on Earth time scale, but we'll focus on the important stuff. So I'm going to tell you what you need to know. Make sure you pay attention to the details and remember what I'm telling you to remember because those will be the important parts. So what do I mean by that? We left it off after we talked about the endosymbiosis that explained how archaea and prokaryotes have kind of merged into that eukaryote part, right? And it's all after enfolding of a membrane for some organelles, but most importantly, endosymbiosis for the mitochondria and chloroplasts, right? We talked about the increase in oxygen, the photosynthesis that started 3.7 billion years or so ago. And now we are going to explain that slew of diversity that happened relatively recently, right? Because 1.5 to 0, and more importantly, 500 million years, it's really all it took to get most of that diversity. And when I say all it took, it's still 500 million years. It's a lot of time, right? Notice that photosynthesis on land is really recent. So let's take a look at that. Earliest fossil we have is a Precambrian period. We don't really know what those organisms are and what they were doing, but that's it. That's what we have in Precambrian. So if you look at the scale of the Precambrian, is all that area here in orange, with that deep orange. It's a super eon when we put everything because we cannot be bothered to break it down more. We have some eons broken down like the Hadean, Archean, Proterozoic. I don't really need you to know any of that. We will mostly focus into the Phanerozoic eon. If I cannot pronounce something, it's probably not important. The eon is not really important, but you need to know those three eras: Paleozoic era, Mesozoic era, and Cenozoic era. We start with the Paleozoic era. Do you need to know the dates? Roughly 500 to 250 million years. Remember that. The Cambrian, aka the age of invertebrates. Look at this. It looks like the so for those of you playing video games, Subnautica, the game, you may have played it or not. It's a Leviathan almost. Every sci-fi or video games horror is inspired from real biology. The Cambrian period here, notice something important. Age of invertebrate, and yet in the similar time you have the first plants. The first plants on land is just after, but you have the first animals there, so it's not just invertebrates. It's unicellular organism, other multicellular organism, protists, other stuff are there, not just the age of invertebrate, only invertebrate. It's just the most common fossils that we found from that period is invertebrate. So following that, during the Cambrian age of invertebrates, following that, don't care really about the names, just remember that's the first land plant. Really small, the eye of a needle, right? That's where you still you finally have plenty of plants, but notice that you have diversification and expansion of those plants widely during that period. Then when we go to the Devonian, that's a little bit further along, and that one is the age of fish. That's when we find a ton of fishes. Doesn't mean there's nothing else. There's still invertebrates in the background, still protists, still plants. Followed by the Carboniferous. Carboniferous in French means pine tree. And I'm sorry that in English it doesn't really mean that. But that's how I remember it. It's a lush tree era, so it means a lot of wetlands, which means amphibians. That's really how I remember it. You need to find a way to remember it for you. Maybe it's like, I know, carbon, wetlands, with peat, things like that. But it's the age of amphibians. So once again, lots of fish, lots of other animals, but the amphibians are just taking over. And amphibians are nothing but fish who got out of the water. And then we get to the Permian, so now it's closer to it's actually the end of the Paleozoic. And the Permian, you have to think about Pangea, you have to think about that one mass land and massive extinction. When there was raising temperatures, depletion of oxygen, that leads to a big mass extinction of animal species on the planet. This now we switch gears to the Mesozoic era, and this one may be the easiest one to remember, an entire era just for dinosaurs. Jurassic Park, the movie, the book, all of those, the games. Remember that Triassic, Jurassic, Cretaceous, all of those are reptiles. So age of reptiles. Once again, not just reptiles. At the same time, birds, mammals, flowering plants, lots of cool stuff happening, right? I emphasize that very much. Age of reptiles, just majoritarily reptiles, not only reptiles. Remember that age is 250 to 65. 250, 60, 250, 60, 500, 250, 60. Paleozoic, Mesozoic, and then the Cenozoic, which starts after the giant meteorites that just put an end to the reptiles. We switch to the Cenozoic, that's recent time, that's us. And in that era, we see all the humans, but mostly mammals. That's mammals that's really important here. Once again, we're emphasizing you have fish, you have birds, you have other stuff, not just mammals. And during the Cenozoic, mammoth, ice ages, a lot of cool stuff like that. So we're gonna leave it at that. Remember 500 to 50, 60. Remember those dates: Paleozoic, Mesozoic, Cenozoic, age of invertebrates, age of fish between the two, first land plants, then age of amphibians, then age of reptiles, then age of mammals. Right? You need to remember those order. So if you remember your dates and the age of reptiles, that Mesozoic era, you 250, 60, you'll be able to just play around during the exam. But that means you understand how things are ordered. So you have to realize you don't have reptiles before fish because life starting in the water, right? So keep those in mind and you'll be okay. But yeah, hopefully this has been useful. Take care. Bye.